Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tarek. Today we will discuss another derivative rule with the name power rule. We studied power rule before this, but in here I am repeating with little changes. So this is the given function y is equal to bracket start f of x bracket closed raised to the power n. This is the given function. So how to find its derivative? So we will take this power down to the coefficient of the function, and then we will subtract 1 from the power times we will take the derivative of the function within the brackets. So in here we will take the derivative of the terms within the brackets. In here within the brackets we have f of x. So this is the derivative of the function using power rule, that d over dx of y or dy over dx is equal to d over dx of the function f of x whole raised to the power n. Now how to find its derivative? Dy over dx is equal to, we will take this power n down and write in the coefficient of the function. So we take this power n down and we write in here. So this is, we write the exponent n in the coefficient of the function, and we subtract 1 from the power n minus 1. This dot means zarab times, again we take the derivative of the function which is within the brackets. So within the brackets we have the function f of x, and times this is the derivative of those terms which is within the bracket, which is inside the bracket. So power rule we little modify. I'm again repeating that we will take the power down to the coefficient, subtract 1 from the power, and times means a zarab. We will take the derivative of those terms which are inside the bracket. So in here inside the bracket we have f of x, and this is times derivative of those terms which are inside the bracket, which is f of x. So its derivative a prime of x, where a prime of x is the symbol of the derivative of the function inside the brackets. Now let me further clarify this with one simple example. For example, find the derivative dy over dx of the function if the function is y is equal to bracket start 2x plus 3 bracket close whole raised to the power 2. This is a given function with an exponent 2. Now what to do? We will take the power 2 down to the coefficient, subtract 1 from the power, and times find the derivative of the function within the brackets, which is 2x plus 3. So I am applying here dy over dx is equal to d over dx bracket start 2x plus 3 bracket close whole raised to the power 2. I just applied derivative on the left hand side of the function, means y, and I applied derivative on the right hand side of the function 2x plus 3 whole raised to the power 2. For the time being we just apply symbol of the derivative. In the next step I am taking derivative. So dy over dx as it is equal to, this is the power rule, we will take this power 2 down to the zarib. I am writing in here bracket start 2x plus 3 bracket close 2 minus 1. We will take the power down, subtract 1 from the power, and times I am again taking derivative of those terms which are inside the bracket. So d over dx is the symbol of the derivative I am applying on the terms within the bracket. So within the brackets we have 2x plus 3. So d over dx of 2x plus 3. So this is the difference between the simple power rule and little modified power rule. Now in the next step, dy over dx is equal to 2 as it is 2x plus 3 2 minus 1 times we will apply derivative on the first term 2x plus we will apply derivative on the second term 3. We study the function rule that we will apply individually derivative on each term. Now dy over dx is equal to 2x plus 3, 2x plus 3 raised to the power 1. Now this 2 is constant. So we will take this 2 outside and take the derivative of the function x with power 1 only, plus d over dx of 3. Now dy over dx is equal to 2 as it is, 2x plus 3 raised to the power 1 as it is, 2 as it is, and the derivative of the variable with single power means derivative of the x with power 1 is 1 and derivative of the constant 3 is always 0. Now dy over dx is equal to 2x plus 3 raised to the power 1 multiplied by 2, and dy over dx is equal to 2 multiplied by 2, 4 into 2x plus 3, and now we will multiply this 4 inside the bracket. So dy over dx is equal to 4 zarbi 2x 8x plus 4 zarbi 3 12. This is the derivative of the given function. ما ایگا پارا دوباره در زبان دری واضح میکنیم. اینجا ما پاور رول را دوباره مطالعه میکنیم. خو اینجا ما یک چیز اضافه میکنیم که پیش از این که پاور رول بود ما صرف پاور را پایین آوردیم او از پاور یک کم کردیم، منفی کردیم. اینجا یک مودیفیکیشن، یک چینج در پاور رول یہ میآید که ما وقتی که exponent توان پاور را پایین در ضریب بیاریم از توان یک منفی کنیم، بعد از او باید ما derivative و terms بگیریم که او در داخل بریکت قرار داره. یعنی یہ طریقه شد که باید ما اول خو پاور رول اپلای کنیم، توان exponent یا پاور را در ضریب بیاریم، از پاور یک کم کنیم یک منفی کنیم. خب پس در حالت ضرب یعنی تایمز ما derivative و terms بگیریم که او در داخل بریکت است. مثلا یہ فنکشن است f of x در داخل بریکت قرار داره و هول توان n است. یہ چطور derivative میشه؟ dy over dx برابر با d over dx of the function f of x whole raised to the power n. خو آل dy over dx برابر ما چی کردیم؟ توان n را پایین آوردیم، نوشته کردیم در جای ضریب فنکشن، در حالت ضریب آوردیم، از توان یک منفی کردیم او تایمز یعنی ضرب ما دوباره derivative گرفتیم از او terms که در داخل بریکت قرار داره. در داخل بریکت اینجا f of x است، خود تایمز ما derivative گرفتیم، مشتگیری کردیم او فنکشن f of x که در داخل بریکت قرار داره. خو چی نوشته کردیم؟ f prime of x او f prime of x علامه derivative است. یعنی به این معنی که ما اول پاور رول اپلای کردیم او پس او terms او فنکشن که در داخل بریکت قرار داره از او دوباره مشتگیری کردیم، derivative گرفتیم. خو f of x است، اینجا f prime of x یعنی derivative of the function نوشته کردیم. ما آله ایره مزید با کمک یک اگزامپل تشریح میکنیم که derivative معلوم کو dy over dx question mark یعنی مشتگیری کو اگر فنکشن یس y برابر با 2x جمع 3 هول بتاوانی 2. یہ فنکشن است، سوال میکنه که مشتگیری کو مشتق معلوم کو. خو ما در اول مرحله خو سیمبول علامه مشتق را به طرفین وضع کردیم، اپلای کردیم. dy over dx برابر با d over dx او یہ فنکشن است 2x جمع 3 هول بتاوانی 2. خو ما اینجا derivative اپلای میکنیم، علامه derivative که باید مشتقگیری کنیم. dy over dx خودش برابر با چی شد؟ آل ما اول خو پاور رول اپلای کردیم. پاور رول چطور اپلای میشه؟ توان یا اکسپوننت یا پاور باید در حالت ضریب آورده شوه، باید بیاریم اینجا اوازی پاور باید یک منفی کنیم. او عمل ما کردیم و کار کردیم، دو را در حالت ضریب نوشته کردیم، از دو یک منفی کردیم، ضرب یا تایمز. حالا دوباره ما باید مشتگیری یه ترمز کنیم که در داخل بریکت قرار داره. در داخل بریکت یک 2x او جمع 3 است، یه دو ترمز است. خب باید ما در حالت ضرب derivative یہ terms جدا جدا بگیریم. d over dx اپلای کردیم derivative symbol او آل بچی به 2x جمع 3. dy over dx برابر بچی شد دو خودش 2x جمع 3 به توان 1 از دو که 1 برای 1 میمانه times اینجا باید ما d over dx یعنی مشتقگیری اول terms کنیم 2x جمع مشتقگیری دوم terms کنیم 3. dy over dx برابر به دو ضرب 2x جمع 3 به توان 1 خودش یه دو اینجا ثابت است به اینجا بیرون کشیدیم او ما مشتق میگیریم از فنکشن x به توان 1 او جمع d over dx of 3. dy over dx برابر به دو خودش 2x جمع 3 به توان 1 خودش ضرب 2 خودش اینجا مشتق x به توان 1 است او مشتق 3 که ثابت است و 0 است. so dy over dx برابر به 2 ضرب 2x جمع 3 به توان 1 ضرب 2 ضرب 1 2 ضرب 1 2 میشه. آله 2 ضرب 2 ما ضرب کردیم در آینده استپ dy over dx شد 4 2 را کتی 2 ضرب کردیم 4 شد 2x جمع 3 به توان 1 2x جمع 3. آله در آینده استپ ما 4 را در داخل بریکت ضرب میکنیم. خود dy تقسیم dx چی شد برابر به 4 ضرب 2x 8x جمع 4 ضرب 3 12. Exponential function with base e. This is another rule that how to find the derivative of those function which carry base e. So the methodology of the function with base e is this, that we will take the derivative of the exponent only and times we will write the function as it is. I am again repeating that to find the derivatives of all those functions where base is e, so we will take the derivative of the exponent of the power of the tawan only and times we will repeat the original function as it is. Let me clarify with one example. This is the exponential function with base e and exponent tawan is f of x. So how to find its derivative? We will apply derivative symbol on both sides. dy over dx is equal to, we will take the derivative of the exponent only. So exponent is f of x only. Power is f of x. Tawan is f of x. We will find its derivative. This is standard form, general form. So f of x is a function and f prime of x is its derivative. And I will write in multiplication form the original function as it is. So times, this dot represent time means zarab. Repeat the original function as it is. So original function is e raised to the power f of x. I am repeating again in here e raised to the power f of x. So this is the derivative of those functions with which carry base e. I will clarify with one example. For example, y is equal to e raised to the power x. Suppose this is exponential function with a base e. Now, as we know that the function with base e, to find its derivative, we will just find derivative of the exponent only times the function as it is. So what is the exponent in here? X. First, I am applying symbol of derivative on each side. D over dx of y is equal to d over dx of the function e raised to the power x. Now dy over dx is equal to, we will take the derivative of the exponent only. So in the exponent of the given function we have x. So I am finding derivative of the x times, I will repeat the given function as it is. So times e raised to the power x. Now dy over dx is equal to, what is the derivative of x with the power 1? Always 1. And we will repeat the function as it is in multiplication form. So 1 times the function e raised to the power x and dy over dx is equal to e raised to the power x. For example, y is equal to e raised to the power 2x plus 10. I am repeating another example. So again methodology is very simple, that we will take the derivative of the exponent only times repeat the function as it is. So first I am applying derivative symbol on both sides. sorry, I am taking derivative, so dy over dx is equal to, we will take the derivative of the exponent, tawan only, so d over dx of 2x plus 10. 2x plus 10 is actually in the power. 2x plus 10 is actually in the tawan. So we will take only the derivative of the exponent I am taking. I am applying derivative symbol on the two terms 2x plus 10 which are existing in exponent, and times I am repeating the original function e raised to the power 2x plus 10 as it is. Now dy over dx is equal to, we will apply derivative on each term individually. D over dx of the first term 2x plus khudish, d over dx of the second term 10, and times e raised to the power 2x plus 10 as it is. Now dy over dx is equal to, so this we will the derivative of the function 2x is actually only 2. We will take the constant outside and derivative of the x is 1, so 2's are 1, 2, and the derivative of this 10 is 0 times the function as it is. So dy over dx is equal to 2 plus 0, 2, and 2 times e raised to the power 2x plus 10. So this is the way to find the derivative of the function which carry base e. ما ایگه پارا دوباره در زبان دری هم واضح میکنیم او فنکشن ها که در او قاعده ای باشه derivative او باید چطور گرفته شود. مثلا یک فنکشن است که y برابر به ای به توان f of x است. اینجا فنکشن که است او قاعده ای داره. طریقه کار که چطور مشتق گیری شو او یه است که ما باید صرف فقط مشتقگیری توان را کنیم. ما فقط باید دریویتیو اکسپوننت بگیریم. ما صرف فقط باید مشتقگیری توان اکسپوننت یا پاور را کنیم او در حالت ضرب و اوریجنل فنکشن باید واپس نوشته کنیم. مثلا یہ فنکشن است y پرایم چی میشه؟ dy over dx چی میشه؟ مشتقگیری توان در توان f of x است، خود مشتق f of x f prime of x نوشته کردیم او در حالت ضرب و اوریجنل فنکشن دوباره تکرار کردیم. یہ طریقہ کار است که باید مشتق توان گرفته شود او در حالت ضرب باید او فنکشن دوباره ریپیٹ شود. یہ ما با کمک یک اگزامپل دوباره تشریح میکنیم. y برابر با ای به توان x، یہ فنکشن قاعده ای داره. با ای وجه ما اول خو علامه دریویتیو را به طرفین اپلای کردیم. dy over dx برابر با d over dx ای به توان x. حالا dy over dx برابر با ای باید ما مشتقگیری یا دریویتیو توان کنیم. خود در توان x است، به ای وجه d over dx of x او ضرب در حالت ضرب ما فنکشن دوباره نوشته کرده میرم. dy over dx برابر به چی میشه؟ او فنکشن او مجهول که بلندترین توان یک داره، مشتق او همیشه یک است او تایمز فنکشن as it is خودش را روان است. خود dy over dx برابر به چی شد؟ یک ضرب ای به توان x ای به توان x شد. ما یک دیگه اگزامپل میگیریم. فور اگزامپل y is equal to e raised to the power 2x plus 10. یم یک فنکشن است که قاعده بیس او ای است. حالی دوباره اول خما دریویتیو گرفتیم، مشتقگیری کردیم به طرفین. سیمبل دریویتیو به طرف چپ اپلای کردیم او سیمبل دریویتیو به طرف راست. خود dy over dx برابر به چی شد؟ باید ما مشتق توان را پیدا کنیم، مشتقگیری توان کنیم. در توان 2x جمع داست، به این وجه ما d over dx اکسپوننت کردیم. در اکسپوننت 2x جمع داست ما d over dx of 2x plus 10 باید معلوم کنیم او در حالت ضرب باید فنکشن را دوباره ریپیٹ کنیم. So dy over dx is equal to آله derivative 2x 2 می آیا چرا که 2 ثابت است اینجا بیرون کشیدیم او derivative مجهول به توان یک همیشه یک است. خود 2 ضرب 1 2 میشه او derivative ثابت عدد همیشه 0 او ما فنکشن اوریجنل در حالت ضرب اینطور میاریم پیش را روان کردیم. را روان است ای به توان 2x جمع ده हाले dy over dx बराबर ब 2 जमा 0 2 और در حالت ضرب वो ओरिजिनल फंक्शन خودش खुबा एक तरीका मेशा के मुश्तगिरी वो फंक्शन शवा के वो कायदा इदारा. Now logarithmic functions, those functions which carry log, natural log, like for example y is equal to ln f of x, where ln is the symbol of the natural log and f of x is the given function under the log. So what is the methodology to find the derivative of those functions which carry log? So methodology is this, that we will take the reciprocal of the function under the log and times derivative of the function. Yani for example, y is equal to natural log f of x. This is the given function. F of x is the function under the log. To find derivative of this function, first I will take the reciprocal of the function. So y is equal to log f of x. Dy over dx is equal to d over dx log f of x. So in the very first step, we will take the reciprocal of the function which is the under the log. So under the log we have the function f of x, and I will take its makus, its reciprocal, which is 1 divided by f of x. Dot mean times I will take the derivative of the function f of x which is under the log. This is the methodology. Means take the reciprocal of the function which is under the log times derivative of the same function. So in here function f of x is under the log, I take its reciprocal times I am taking derivative of the same function. So dy over dx is equal to 1 over f of x times f prime of x. So this is the way to find the derivative of those functions which carry natural log. For example, y is equal to ln x. So in here we have the function x under the log. How to find its derivative? We will take the applied derivative symbol on both sides. So dy over dx is equal to d over dx of ln x. Yani I am applying derivative on the natural log. So what is methodology? Reciprocal of the x. So dy over dx is equal to 1 over x. This is makus of the x. Barak se x. 1 over x yani makus, reciprocal. And I will find the derivative of the x which is under the log. So d over dx of x. Dy over dx is equal to 1 over x. And derivative of the x with power 1 is always 1. So dy over dx is equal to 1 over x. This is the derivative of the function that we find. Let me put another example. For example, y is equal to ln. Ln mean natural log. N stands for natural, L for log. With a base e. Why we call this natural log? Because its base is e. So for example, y is equal to ln and the function under the log is a 3x square jama 2x manfi 10 bracket close, parenthesis closed. So this is the given function. We will apply derivative on the left hand side and then we will apply derivative on the right hand side. So dy over dx is equal to d over dx of the ln 3x square jama 2x manfi da. Now dy over dx is equal to, in the very first step, we have to take the reciprocal of the function under the log. So under the log we have 3x square plus 2x minus 10. I am taking its reciprocal. So this will be 1 over 1 divided by 3x square plus 2x minus 10 and times I will take the derivative of the function under the log. So under the log function is 3x square plus 2x minus 10. I am applying derivative d over dx 3x square plus 2x minus 10. Now dy over dx is equal to 1 divided by 3x square plus 2x minus 10 as it is times this 3 is constant, so I take outside and I apply derivative on the function with power 2 d over dx x murabba plus this 2 is constant, I take outside and I am applying derivative on the x d over dx of x and minus d over dx of constant. So dy over dx is equal to 1 over 3x square plus 2x minus 10. Now 3 is as it is, x raised to the power 2, we will apply here power rule. So take this power down. So we take the power down and we subtract 1 from the power 2 minus 1 plus derivative of the x with power 1 is always 1 and derivative of the constant is 0. So dy over dx is equal to 1 divided by 3x square plus 2x minus 10 times 3 as it is 2x 2 minus 1 1 plus 2 1 2 and dy over dx is equal to 1 over 3x square plus 2x minus 10 and times 3 multiplied by 2x 6x and plus 2. This 3 is in multiplication form with 2x only, not with this 2. So 6x plus 2, and now dy over dx we can write 6x plus 2 whole divided by 3x square plus 2x minus 10. Because this is 1 divided by 3x square plus 2x minus 10, this term, these three terms are in the makhraj, in the denominator. So 6 plus 2 divided by 3x square plus 2x minus 10.